So on this question, we want to simplify, write your answer without negative exponents. Assume that no denominators are equal to 0. So we don't have to worry about dividing by 0. We have the expression q to the negative 9, j to the 8th, g over q to the 6th, j to the negative 2, and g to the 7th. So the way that I like to approach this problem is to adjust these negative exponents first. Because having a negative exponent means reciprocal, if I just move the position of these, it applies the negative, gets rid of the negative. So I can move this factor to the denominator and the negative goes away, move this one to the numerator and the negative goes away. So my first step is j to the 8th times j squared, g over q to the 6th times q to the 9th, and then g to the 7th. Now that those negative exponents are gone, I'm focusing on my product rule and quotient rule. Product rule is when you're multiplying expressions with the same base. Quotient rule is when you're dividing expressions with the same base. With the product rule, you add the exponents. With the quotient rule, you subtract the exponents. So I would have j to the 10th when I add the j exponents together. And I've got these q variables with the same base multiplied. So I'm going to use the product rule on them to add the exponents. That gives q to the 15th. And then for the quotient rule, I would divide these two, subtracting the exponents. So this has an exponent of 1 minus 7, that's negative 6. And because it's negative, I'm going to put it in the denominator. Make it g to the positive 6. So my final answer here is j to the 10th over q to the 15th, g to the 6th. Okay, so here's another one. We're going to work on this one is finding the quotient and the remainder using long division. And we have x squared plus 10x plus 22 over x plus 3. So let's set up our long division. We're taking x plus 3 and dividing it into x squared plus 10x plus 22. When you're doing long division, you want to focus on your first terms. How many times does x divide into x squared? That's x times, or if you want to think about it as multiplication, x times x gives you x squared. X times x is x squared. X times 3 is 3x. And on this step, we're supposed to subtract. So we're going to change the signs here to do that subtraction. And x squared minus x squared is 0. 10x minus 3x is 7x. And I'll bring down the next term, which is 22. Once again, we're going to focus on the first terms. We're repeating that last process over again. X divides into 7x 7 times. 7 times x is 7x. 7 times 3 is 21. On this step, we're going to subtract, change the signs. 7x minus 7x is 0. 22 minus 21 is 1. And this is where we're done. We have the quotient being x plus 7 and the remainder 1. So just a piece of advice. Some people get lost in the details, lost in the process here. If you remember your long division with numbers, it's the same process as that. So if we just think of dividing 5 into 2043, you focus on the first digit of 2. 5 doesn't go into 2. Now you're going to do 2 digits. 5 goes into 20. 5 goes into 24 times. 4 times 5 is 20. Then you subtract. You bring down the next term. 5 into 4 doesn't go. Bring down the next term. 5 go into 43. goes 8 times. 8 times 5 is 40, and you subtract. So if you're forgetting little details about that overall process, go back to the long division that you learned when you were learning dividing numbers. Okay, so here we have another long division problem. We want to find the quotient and the remainder using long division. On this one, we have x to the fourth plus 3x cubed plus 12x minus 15 divided by x plus 4. Now, there is one difference in this example versus the previous one, is that we are missing an x squared term here. We have 4, 3, missing the 2, 1, and then constant we consider to be a 0. So because we're missing a term, we don't have to, but we put in a placeholder, and the placeholder helps us to make sure that we only combine like terms together and make sure everything is lined up. So we're going to set this up as x plus 4 divided into x to the fourth plus 3x cubed. We're going to put that placeholder in the x squared. So 0x squared is 0. So we're not changing our problem. And like I said, this is just making sure that all of the like terms line up. And when they line up, those are the ones that we add together. So we're going to focus on the first term. In each of these, x divides into x to the fourth, x cubed. X cubed times x is x to the fourth. X cubed times 4 is 4x cubed. Then we're going to subtract. X to the fourth minus x to the fourth is 0. 3x to the fourth minus 4x cubed, that's a negative 1x cubed. And we'll bring down that next term. We repeat that process over again. Focus on the first terms. X divides into negative x cubed, negative x squared times. We multiply that negative x squared times both of these terms and write it down here. Negative x squared times x is negative x cubed. Negative x squared times 4, that's a plus x squared. Excuse me, that should be a minus. Minus x, 4x squared. And we're going to subtract. We'll change those signs to subtract. Negative x cubed plus x cubed, that's 0. And we have 0x squared plus 4x squared. That's 4x squared. So you can see that placeholder was convenient here to make sure that we were adding the correct thing. Otherwise, we would have brought this term down, and we would have terms that are not like terms lined up. So let's bring down that next term of 12x. X divides into 4x squared, 4x times. 4x times x is 4x squared. 4x times 4 is 16x. We're going to subtract, change the signs, and we get 12x minus 16x is negative 4x. Let's bring down the next term. Repeat that process over again. X divides into negative 4x, negative 4 times. And negative 4 times x is negative 4x. Negative 4 times 4. Excuse me, I made a mistake there. That's a 15. Negative 4 times 4 is negative 16. Change the signs for your subtraction. Negative 4x plus 4x is 0. Negative 15x plus 16 is 1. And we have now our quotient and our remainder. So the quotient is x cubed minus x squared plus 4x minus 4, and the remainder is 1. On this example, we want to factor this r cubed plus 8 completely, and we're going to use the sum or difference of cubes. So let's write out the sum of cubes formula. It's a cubed plus b cubed. And that factors to be a plus b times a squared minus ab plus b squared. So when we want to factor with this pattern, we have to recognize what a and b are, and then we use those to create our factoring pattern. So in this example, we have r cubed plus 8. And 8, we want to see if we can write that as a perfect cube. 2 times 2 times 2 is 8. So we can write 8 as a 2 cubed. And this helps us recognize what the A is r, and B is 2. And we'll follow this pattern because we have the sum of cubes. So we're going to do a plus b, r plus 2. A squared, that's r squared, minus ab. So ab is r times 2, or 2r, plus b squared. B is 2. 2 squared is 4. So this is the pattern that we factor for this sum of cubes. R plus 2 times r squared minus 2r plus 4. On this example, we want to solve the equation 8z squared minus 14z plus 3 equals 0. And whenever I'm solving an equation that has a higher power, higher than 1, like this, I want to group all the terms to the same side. So I have the equal 0. And then I'm going to try to factor this expression. You should first try to factor the greatest common factor, but 8, 14, and 3 don't have any factors in common. And so because I wasn't able to factor this 8 out, I know that this is a harder trinomial. Whenever you have this coefficient being 1, it's a pretty simple case to get the answer, but when this coefficient is not 1, you have to use a harder method, a more difficult method. So the method I'm going to work out with you guys here is the grouping method. That's the one that you all seem to prefer. So what you do is you multiply the coefficient from the first term with the constant. So it's 8 times 3. That gives you 24. And you're looking for factors of 24 that add to negative 14. So let's look at factors of 24. That's 1 times 24, 2 times 12, 3 times 8, 4 times 6. And I'm seeing this this one right here with the 2 and the 12 to get 14. So I'm going to need negative 2 times negative 12 to get a positive 24, and negative 2 plus negative 12 to get a negative 14. So I found my pair of numbers. Once I get that pair of numbers, I'm going to take the middle term and I'm going to split it into 2 terms using those numbers that I just found. So that will be a negative 2z and a negative 12z. The first term stayed the same, and the last term stayed the same. So we're just splitting the middle. Now that we have 4 terms, we're going to use that grouping method. Group 2 at a time together. Group the greatest common factor out of each group. So for the first group, I have 2z as my greatest common factor. If I factor that out, I get 4z minus 1. For the second group, I have a greatest common factor of 3. And since this is negative, I'm going to make this one negative. So let's factor a negative 3 out. Factoring in negative 3 would leave me with 4z minus 1. If your grouping method is working, you should have a common binomial, and you're going to factor that common binomial out. So I'm factoring 4z minus 1, and I'm left with 2z minus 3. And I'll set each factor equal to 0. So at this step, I'm using what's called the zero product property. I'm multiplying two numbers to get 0. The only way that can work is if one of these numbers is 0. So 4z minus 1 equals 0. 2z minus 3 equals 0. I'll solve each of these equations, add 1 to both sides. That's 4z equals 1. Divide by 4. So z equals 1/4. Here I'll add 3 to both sides to get 2z equals 3. Divide by 2, and z equals 3/2. So we've solved that equation by factoring and using the zero product property. So for this one, we want to find all real solutions to the equation 2r cubed minus 2r equals negative r squared plus 1. So as I said a moment ago, when we're trying to solve an equation with a higher power, we want to move all the terms to the same side. So I'm going to add r squared to both sides. I'm going to subtract 1 on both sides. And that gives me the equation 2r cubed plus r squared minus 2r minus 1 equals 0. And we want that equals 0 because later on we're going to use that zero product property, and we need 0 on one side. On the left-hand side, we're going to factor. We have 4 terms. There's no greatest common factor, and with 4 terms, we can try our grouping method. We'll group 2 terms at a time. Factor the greatest common factor out of each group. So for the first group, there's r squared in common, and I'm left with 2r plus 1. For the second group, 2r and 1 don't seem to have anything in common, but we can use 1 as a factor of any number. So we'll use 1. And because we have a negative here, we'll use a negative in our greatest common factor. So factor out that negative 1, and you get 2r plus 1. We have our common binomial, so our grouping method is working. We'll factor out 2r plus 1, and what's left is r squared minus 1. The r squared minus 1 can be factored more. This is a difference of squares. It factors to be r plus 1 times r minus 1. So difference of squares, just as a reminder, is a squared minus b squared. That pattern factors to be a plus b times a minus b. Once you have it completely factored, you're going to use the zero product property. We'll set each factor equal to 0. 2r plus 1 equals 0. R plus 1 equals 0. R minus 1 equals 0. We'll subtract 1. We get 2r equals negative 1. Divide by 2. R equals negative 1/2. Subtract 1. R equals negative 1. Add 1. R equals 1. So we got 3 solutions: negative 1/2, negative 1, and 1. Thank you for checking out my videos. Have a great day.